So our first speaker is Martin Hilbert. He is an assistant professor in the Department of Communications at UC Davis. In addition to holding a PhD in communications from the prestigious Annenberg School at USC, he also holds a PhD in economics and social sciences. Martin's work truly embodies the mission of ISS. It's truly multidisciplinary. His publications and research interests span the fields of communication, political science, public policy, and economics. And today we'll be giving a talk entitled Big Data for the Social Sciences. Thank you.
Thank you very much. So since I've been given the honor to open up this important event today, I thought I will try to rise to the occasion and go through everything. So I will try to talk about the theory, the practice, and the limits of big data for the social sciences. So basically, we've created this mind-boggling amount of information during the last couple of decades, right? Once I spent about 3 or 4 years of my life where I actually tried to estimate how much information there is in the world. The most amazing thing about that, I thought, was that nobody before me took a serious shot at creating these time series. I pretty soon found out why. It's because it's pretty boring to count bits all day long. But once it was done, it was quite insightful. So how much information is stored in all of our technological devices? Paper, video, the little chip on the back of your credit card. So the Washington Post made this very interesting graph for me. And you can see here the white part is the analog information in the world. The green part is the digital, which is very little. And after the year 2000, the amount of digital information basically explodes, with the result that the amount of information in the world explodes as well. And digitalization happened in a historical blink of an eye, basically. Back in the late 80s, less than 1% of the world's information was in digital format. By now, more than 99% of all the information in the world that is stored is in digital format. And it has grown information tremendously. If we would, for example, take all the world's stored information and convert it into the informational equivalent of double-printed book paper, back in the late 80s, we could have covered the entire world, all the terrestrial territory in the world, with one layer of paper, of this double-printed book paper. Every square inch, the Sahara Desert, top of Kilimanjaro, your kitchen and bathroom would be covered with one piece of paper. In 2007, that has grown to one entire book, 250 pages book. In 2011, already to 2 layers of book. And right now, we would stand literally until our knees in information with 5 layers of book everywhere. That's how much information the world can store. I could give you many more of these nice analogies. I had to elaborate them all recently because now comes a shameless plug. On Sunday, check it out, this Sunday, the new documentary on Discovery Channel, Mankind from Space, where you can see me in HD telling you all about how digitalization happened, and we will look at it from space. I swear, I have no idea how these documentary filmmakers come up with that, but it looks like a really cool production. And somehow for me it always, look, this The Economist made that, it's from space. Now this Discovery is from, I don't know what digitalization has to do with space, but it seems to be a cool thing to combine, so check it out. It starts this Sunday and it will go on for the next month or 2. All right, so enough of that. Let's become a little bit more serious. The theory behind, why do we care about big data? Well, we don't care about big data because we stay knee-deep, if we can stand knee-deep into equivalents of books. No, we care about big data because, as international organizations tell us, data is the new source of growth. And private consultancy companies tell us about the need to recognize the potential of harnessing big data to unleash the next wave of growth. And private sector entrepreneurs tell us straight out, data, that's the new oil. Straight, that's what it is. Right? That's how it is. It's as important. So while the last 200 years we were driving an industrial economy, now we drive an economy that is purely based on data, on information. Now, if you look into the textbooks, you find very little about how growth can come from information, right? Something as if you always need, you need capital, you need labor, you need institutions, you need cultural practices, everything you need to grow anything we want in society, we want to evolve. But information, it's a quite funny thing. You don't usually find that in the equation. So for the last 2 or 3 years, I spent a lot of time thinking about that and basically decomposing information, decomposing growth into information. So I'm in the Department of Communication, and I work a lot with the mathematical theory of communication, which is based on Claude Shannon, the father of information theory. And what Shannon basically taught us, that information is the opposite of uncertainty. And if you look at it like that, then you have a good understanding of why this information matters, because the world is full of uncertainty, right? We don't know what will happen in the future. The world is full of uncertainty. Now, information is the opposite of uncertainty, and communication is the process of uncertainty reduction. That's how information theory tells it what it is. And so the less uncertainty you have, the more information you have, the more you can grow. To make a rhyme of it, the more you know, the more you can grow. Right? It's very intuitive. So for all of us who are intuitively challenged, that's what the formula looks like. Like me, right? I always have to write it out. So don't worry about the details, but what's the interesting? So here we have growth, and here these are all information metrics. So this is here is absolute entropy, this is relative entropy, Kullback-Leibler distance, and this is mutual information. So basically you take growth, you can decompose it actually into information. That's the amazing thing. So, and I found that I was pretty excited. And it always has to do with the environment, that's the E, and the G, that's the future generation of growth. That's the growth outcome. So it's basically a communication process between the environment and whatever you want to grow. And when you communicate more over this channel, the more you can grow. So that's how you can actually think what this formula tells you. So let's go through it, a very simple example. We have this uncertainty here, 6 different environmental futures. We don't know what's happened, and I give you $6. What are you going to do? Well, you're going to bet hedge, right? That's what evolution does. That's what nature does. That's what the people on Wall Street do. Because then Lady Luck rolls the dice, and it turns out, well, at least we survived, right? So the minimum condition for growth is you don't get extinct. So that's perfect. That's how we did. Now we grew. Now Shannon gives us one bit of information. What's a bit of information? According to Shannon, that's a reduction of uncertainty by half. That's how he defined what a bit is. So the bit is the reduction of uncertainty by half. So I give you a bit of information now. What happens to my uncertainty? I have uncertainty of 6 different. Now I say, well, reduce uncertainty by half. Don't worry about the right half, just worry about the left half. So now you have half the uncertainty only. What do you do with your $6? Well, you would distribute them like this as well, right? Now, Lady Luck rolls her dice, and what happened? We doubled growth. So while we got left with $1 here, we got left with $2 here. And actually, all over this formula as well, this is a very trivial case, extreme case, what it says that the reduction of uncertainty by half, this 2, and the doubling of growth, this 2, they are equivalent. They are the same. When I found that out, I was really stoked by it. It's really amazing. So the reduction of uncertainty is the equivalent of growth. So we can really decompose growth just into bits and bytes. And that's how it works. So this 2 and this 2, basically, well, this is a very trivial case. And with this formula, it works like this. To show you a big data case, so always this is kind of like, that's how it looks if you look at it as a communication channel between the environment and the growing system. Let's take an example from big data to make it a little bit more concrete. So you go to Google Trends. Google Trends shows you all the results of search terms that people Googled. And here I looked up how often people Googled chocolate, that's the blue, and diet, that's the red. And you can see, obviously, they're kind of like in a balance, right? They balance each other out. And let's say we have a very innovative entrepreneur, and she focuses on both chocolate products and diet products because she will know, over time they balance each other out. She hedges her bets. And according to this data, she will sell exactly 106 products every week, if we take that as an approximation, and that will stay constant over time. Sometimes she sells more diet, sometimes she sells more chocolate, but over time it will constantly be 106 products, right? Now you look at this big data, it reveals a clear pattern. I reveal this pattern to you, it's pretty intuitive. Chocolate trumps diet during September to December. Chocolate peaks at the end of December, then it takes a drastic drop, and diet peaks in January. So that's how the world thinks about these things. Now, this information reduces uncertainty. I can codify that in bit, and if I use my formula here, I can use that as a growth optimization process. How I do that very similar how engineers optimize communication channels. like just telecommunication engineers, when they optimize a channel bandwidth, they use these same techniques that I use here. So I use these bits, I optimize my communication channel between the environment and the growing system, in this case, the products that are sold. And with that, I can increase the growth rate of this entrepreneur to 260 products a week. So from 100 products to 260 products a week. Why? Well, because the more you know, the more you can grow. It's obvious, right? You adjust your strategy during September differently than during January, differently during the rest of the week. Adjusting to these bits, I can grow more. So actually, that's as I said, it's very intuitive, right? So, but now you can. We are starting to discover how these things work using the same theories that we use to create these own technologies. Now we start to understand, whoa, society basically, what it does, it computes. So that's the theory. That's why we care about big data. Okay, let's move on. So now what's the practice? As practice is, we get all this amount of information that helps us to eventually grow. We get that now for free in this kind of like digital footprint that is left behind. I showed you an example of Google search terms now. And I personally prefer, I don't like the word big data so much. I prefer the word digital footprint. It is much more to it, especially if you're in the social sciences. So we have this digital footprint that's created for free. These are, for example, every time when somebody on Twitter says good morning. Nobody did a study here. No money was spent. It's just the digital footprint when somebody on Twitter says good morning or Guten Morgen, Buenos Dias, Buongiorno, or whatever. And we now can do social science with that. And we find we can prove very interesting things that we always knew. For example, people on the East Coast, they get up earlier than people on the West Coast, and it has nothing to do with the time difference. They really do get up earlier. And now we can show that because we have this digital footprint of it. Another very important source of the digital footprint, of course, are cell phones. Who here uses Gmail on their phone and has location services turned on, or uses Google Maps? Everyone's right? Yeah, then you can go to this website here, and you can see exactly where you've been every day of your life last year. It's recorded. You can look it up. So, for example, here on November 17th, I've been all around Davis. I don't even remember what I did, but Google does. And you can look it up. You can even play a little video. It walks you all around where you've been and so forth. It's very transparent. For any purpose, don't show this to your significant other. It can lead to very interesting conversations. But it's now all recorded. So we can now see this kind of like digital footprint, this fine-grained digital footprint. It's like we are measuring out the world anew, but now with a much more powerful lens. And that's really how it works. So this is the capital of Liberia, and that's what this map of the capital of Liberia looked in August 2014, and 3 months later, it looked like that, right? So we were able to fill in all these little details just because of this digital footprint, because people live there, people use cell phones, and we now know where these people are. In Africa, a significant percentage of the population doesn't even have a birth certificate. We don't even know that they exist. Now we know, because even so they don't have a birth certificate, they do have a cell phone. So we can now track them, and we actually know. So it's kind of like before in the map, there were these big white places where it says, there be dragons, right? And now we go in and can really measure it out. That's why I always say, before big data, doing social sciences was more like trying to do astronomy without a telescope, or trying to do cell biology without a microscope, right? We just couldn't see. 5 years ago, we just couldn't see. And now suddenly we get this amazing amount of information for free, this digital footprint that basically tracks everything that's actually important for the social sciences. And actually also we can now think about things that we never thought. We would never spend money on doing surveys, but now we get them for free. For example, let's get away a little bit from the economics. Marriages, very important. What is really worrisome to humankind in marriages? Well, we can just say, look at what people Google or what people look up on the internet in relation to marriages, and we will find out that sexless marriages is by far the most commonly concern of humankind. It's four times more worrisome than unhappy marriages, and about 10 times more worrisome than loveless marriages. Interesting. Some things we also can now see that we always knew. For example, my wife won't have sex with me is more worrisome to humankind than my husband won't have sex with me, you know, the typical stereotype. But as you can see, it's actually pretty close. You know, now, however, what is actually surprising, if you go to a premarital stage, to relationships, my boyfriend won't have sex with me is twice as worrisome than my girlfriend won't have sex with me. So there's the other way around, right? I don't know what's up with these boyfriends, but it seems to be a big concern of girlfriends nowadays. We can also look at, for example, what people look at when they think nobody is watching. For example, in online dating sites, this here is the age of women that are on online dating sites, and we can basically see that women who are young, about 25, 24 years old, they look for men, they look at the profiles for men, and they think that men are attractive that are a little bit older. So your 25-year-old woman looks at a profile of a man who is like 28, 29, right? And women who get older then, if you're 47, on average you look at men who are about 39. So younger women look at men who are a little bit older women look at men who are a little bit younger. So you have this interesting cross over this diagonal here, right? What's with men? Maybe men are more consistent with that, and they absolutely are. The age doesn't really matter. Men always look at women who are 20. Now, we laugh about these things, and that's like a cocktail party joke, right? Yeah, a cocktail party joke, right? They're like, men are not consistent. Yes, they are. They're always young like women. Ha ha. Now, this is not a joke. This is social science now. This is 3.5 million people. Now, I know, yeah, people stop laughing now, right? This is real social science now. Now, as sad as it might be, that's actually the fact. And nobody actually had to do up a survey, and nobody had to lie. Nobody had to ask some questions and, oh, is it really, do you tell me the truth? No, that's really what they look at. So we can now do observations in real time with millions of people just by looking at what they do. What else? Oh, the year 2015. It is 2015 right now. That's the year when Doc Brown and Marty McFly went back to the future. They came to the year 2015, right? And while we still do not have flying cars, and we still don't have self-tying shoes, and most upsetting for me, we still don't have hoverboards, and we also don't have fax machines on all of our walls. You remember that? These fax machines that you are fired, seriously. But we do have big data. Who would have thought in the 80s about big data? We do have big data. So what can we do with big data in the year 2015? Well, we can use the digital footprint to search for evidence of time travelers. Genius idea, because, you know, if there's prescient content placed on the internet, prescient inquiries submitted to search engines, or direct communication about something they could not have known before, they would give themselves away. Right? So if Doc Brown and Marty McFly were here, they surely used the internet, so they are captured in the digital footprint. We got them. We can look it up. There's no way they could have known some of the things. We would have evidence. Right? So these guys, they really did that. They went through all of it, you know, Facebook, Twitter, Google, Bing, well, just for a couple of terms, a couple of occurrences, but really they looked through it. And they found... Oh, I didn't. No evidence for time travelers was discovered. Anyways, we can also do some more serious things with it. For example, we can use this big data in real time to influence actions. For example, you might have heard the announcement, this call might be monitored for quality assurance purposes, right? Yeah, you always think that the head of human resources listens in to make sure you're treated well, right? And that's usually not what happens. It's usually up to 10 million algorithms that listen to you while you talk, and they classify your personality into rubrics like emotions-driven or opinions-driven or reactions-driven and so forth. And that is then used to match you with like-minded people on the other end and in the call center, right? So, and about 10% of call centers already use that. So you're matched with like-minded, and the result is amazing. It cuts call duration by half, and it doubles customer satisfaction. Because you talk with people who really, some people just want to cry, and some people really just want a coupon. And if you're with people who are like at the same wavelength with you, you can really make that work very efficiently. Now, some of these call center people, they might not even know. They just get matched with that, because last time in the presentation I talked about that. Next day somebody came to me and said, well, Comcast called me, and I'm like, are you measuring my personality? And the guy on the other said, no, I'm also just an emotions-driven person. No, I'm just kidding. So they might not even know, but the algorithms help them to match this up, right? What else can we use the big data for? For example, predictive policing, also to inform our actions. So the algorithms basically tell the police patrols where to take their rounds. And the algorithms doesn't really know why. It can be very spurious correlation. We don't really care. It just says, go by 2nd Street and L and whatever. And you know, the police car then just goes by there. And as a result, crime rates go down for 10%, provenly, and compared also to other cities, just because the algorithm says, go down there. We also use that, for example, to judge homicide parole candidates. So big data in prisons is used. It observes people in prison and judges their behavior, and then the algorithm can predict with 70% accuracy if a convicted murderer would re-engage into a murder or not. Now, the algorithm tells you with 70%, this convicted murderer will re-engage in homicide. What will you do? Will you give him parole or not? Well, obviously not. Now, did he do anything? Well, obviously not. But you're punishing. Because of what? Well, because the algorithm told me, because of data, right? So in Hollywood, they call that pre-punishment. In the Minority Report, right? And that is something, now we go to the limits of big data a little bit. It's something that's very confusing because this digital footprint is so real that we often confuse a proxy with reality. Really, but they're still proxies. They're still just data. They are not reality, but they are so real because it's a footprint. You know, it's real action that we often confuse them with. And that's where it gets very shady. For example, the military, drone operators use cell phone traces in order to guide the drones. As a JSOC drone operator said, it's of course assumed that the phone belongs to a human being who is nefarious and considered an unlawful enemy combatant. And then the drone kills a phone. To say it in the words of the former NSA and CIA director, we kill people based on metadata. Or to say it in the words of the drone operator, this is where it gets very shady. Because it's obviously still proxies, right? And that already gets us to the limits of big data. So we're in an age where it's so impressive, and it gets a little bit confusing sometimes, this digital footprint and what it actually is. So let's go to the last part, the limits of big data, especially for the social sciences. Well, first of all, the rules of basic statistics still apply. A proxy is just a proxy. It is not reality, so that's one. But there's another thing that's very relevant, another limitation that's very relevant, especially for the social sciences, and it has to do with stationarity. And this study shows it very clearly. So in 2009, a group of people from Google created this famous flu trend approximation. So they used search terms, they looked for all the search terms, they matched that with actually flu patterns, and they were able to predict the flu in real time based on what people searched. Just on their search behavior, after matching that, calibrating the algorithm, they were able to predict when the flu would spread. Fantastic, that's very important. We know in real time when flu spreads just by looking at what people Google. We don't have to do surveys and so forth. That can save lives, seriously. Now, they did the same study again 5 years later, and they found out the algorithm didn't work at all anymore. It couldn't predict actually the flu. What happened? Well, what happened is reality changed. People Google different stuff. So the same algorithm that was based on data that was 5 years old didn't work now anymore. And that gets to a very fundamental limit, that data, all kind of data, big or small or whatever, is always from the past, per definition. Something has to have happened once. And only if it's from the past, there's data I can analyze the past. Now, if I have a stationary process, that means if the future is similar to the past, that works perfectly, right? But if reality changes, then it doesn't. For example, think about it this way. So it is true that Facebook, Google, and Twitter, they can predict your behavior better than any psychologist. True, hands down. If your future behavior is the same as your past behavior, if you fall in love, if you change your job, if you get divorced, or you move to a different country, the algorithm will be completely off because you destroyed stationarity in your thing. And data is always from the past, so the best time you can do is this real-time nowcasting, but it's actually also like as soon as you record it, it's past, so you always like try to catch up with the past, right? That's what you can do. And it goes to a fundamental critique of an economist, Robert Lucas, a Nobel Prize-winning economist, and he in the 70s, as early in the 70s, in 76, he critiqued his friends in econometrics, and he basically said, what you guys do is you take a bunch of data, you fit curves to it, then you make policy based on your conclusion, you change the entire dynamic of the system, you change reality, and then you think that your old curves will still apply? No, because you yourself changed it. And that's what we always do in social sciences. So in contrary to physics, in physics, you know, you observe something and it's still there and the sun will still rise tomorrow. In social science, we observe something, then we change it. We kind of like destroy our own achievement, our own model, because it doesn't work then anymore. Because we intervened and we changed the reality. So if there would be something stationary, we will make sure that it will not, because we have this innate drive to make the world a better place. So, but if there is a future that has never been, A developed Africa never existed. A world without poverty and hunger never existed. Data cannot tell us how that is, because we don't have data about a world without wars. We don't. So what do we need there? So there, data gets to a limit, and what we need there, of course, are models, are theories, right? So we have all kinds of theories in the social sciences, and these theories then allow us to create scenarios that don't exist. You can do that with pen and paper, differential equation or game theory, whatever you're comfortable with, or you can do that with computer simulations, and basically you see then you can have scenarios that never existed, because in theoretical models you have these parameters that you can change, and you can even change them to value that never existed in empirical reality. Now you need the data to calibrate your model, but curve fitting alone, blind curve fitting, and that's what big data usually stands for, blind curve fitting, no theory required, does not help you to understand a better world, a world that never existed, right? There you still need theory, so theory is still important, in contrary what many data scientists might tell you, especially for the social sciences, because we all the time change reality ourselves. All right, that was it. So I told you about the theory. Big data is important because it helps us to grow, and we start to understand actually how society computes. We can translate bits into growth. They become a driver of growth. The practice, which is sometimes quite scary and sometimes a little funny, and the limits. There's limits surely to big data. It's not a silver bullet. Thank you very much.